Let's look at the domain of root functions. Now, if you recall from an earlier lesson, we said that the domain is the set of all x values. So if we had a set of ordered pairs, we would just select the x values. But if we have an equation, we have to put all possible x values, and it really would be impossible to make a list because there's an infinite number of things I can put in for x here. So let's look at the cube root function. Well, I can take the cube root of any number as long as I have a calculator. Of course, perfect cubes are great. So, like for example, the cube root of 1 is 1. The next perfect cube root of 8 is 2, and so on. But technically speaking, I could even take the cube root of 7. If I had a calculator, I'd just get a decimal number. But when we're graphing these, we usually like to get perfect cubes. Well, since it's a cube, you could also have negative numbers underneath. That just gives you a negative quantity because a negative times a negative times a negative is a negative. And again, if I wanted to take the cube root of -7, I could do that in a calculator and get a decimal estimate. So the domain for a cube is any number, whether it's positive, negative, 0, whatever. So the domain is any number possible. So when you graph cube roots, the graph will stretch across. In fact, why don't we just go ahead and look at this one right here. Let's make an XY chart. Remember, f of x is the same as y. And let's say I put a 1 underneath there. The cube root of 1 is 1. 1 minus 6 is -5. Let's put an 8 under there. The cube root of 8 is 2. 2 minus 6 is -4. And let's go ahead and do the other ones that I found. If I put a -1 under there, the cube root of -1 is -1. -1 minus 6 is -7. And -8. The cube root of -8 is -2. And then -2, you do this first, order of operations, then we get -2 minus 6 is -8. Let's do one more, let's do 0. The root of 0, whether it's cube, square, whatever, is always 0. And 0 minus 6 is -6. So let's graph these. So we have 1, -5. Stretch this out a little bit, and let me get a different color pen. So we have 1, -5. 1, 2, 3, 4, 5. I have 8, -4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. I have -1, -7. -1, -7. I'm kind of running into my other problem here. And then -8, -8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oops. Anyway, sorry about that. Okay, and then 0, -6. 1, 2, 3, 4, 5, 6. What you're going to get for a cube, it's always going to look like this. Now, it may be up here, down here, shifted one way because of a number outside or a number inside, but it's always going to be the graph going across, and of course it extends forever. So these are usually multiple choice questions, this part here, the graph, and so you're always looking for something that stretches across because x can take on any value. Now let's look at the square root. And if we take a square root, like for example, square root of 0 is 0. Square root of 1 is 1. I'm just doing perfect squares. I could find the square root of 2, but I'd need I'd get a decimal, like 1.4 something, and I don't really feel like graphing that. Square root of 4 is 2. Square root of 9 is 3. Okay, good enough. Okay, let's make an XY chart. Now notice I didn't put any negatives under here. So they do ask for domain. Let's do that first. My domain is the lowest thing I can do is 0 and up to positive infinity. I can't put a negative under here. And let's make an XY chart for our problem. Let's do that out here. Have a little more room. So we got 0, 1, 4, 9. Square root of 0 is 0. 0 minus 6 is negative 6. Square root of 1 is 1. 1 minus 6 is negative 5. Square root of 4 is 2. 2 minus 6 is negative 4. Square root of 9 is 3. 3 minus 6 is negative 3. And we'll see what this looks like. Got 0, negative 6, 1, 2, 3, 4, 5, 6. So my graph needs to be a little bit longer here. And we're always going to get like a shooting star when we do these square roots. You'll see what I mean. 1, negative 5. 4, negative 4. 1, 2, 3, 4. 1, 2, 3, 4. 9, negative 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that goes on, and that's what I mean by a shooting star. So it's not going to extend across, and again, I apologize, this runs into each other. It's not going to extend across like the cube because you have restrictions on the domain.